Hey, good afternoon, all, and welcome to Narragansett Bay Estuary Program's webinar today, our Lunch and Learn series on removing the dams on the Kickemuit River. We are so excited that everyone can join us. So for those of you who may not know, the Narragansett Bay Estuary Program is a federally designated national estuary program administered enacted through the Clean Water Act and administered by the EPA. We are a program partner of Roger Williams University, and we operate using a steering committee and of 30 plus diverse partners who are all focused on water quality, habitat quality, wildlife, the way of life here in the Narragansett Bay region. And so today I'm going to turn over everything to our wonderful partners who have been spending at least a decade, if not more, thinking about how to improve connectivity on the Kickemuit River in Warren, Rhode Island. And that has all come to fruition as last summer, two dams came down. So this starts in about our journey, which you'll hear more about, starts in 1883 when the first of two dams were built on the river to create a reservoir that was actually never used. And so in 2024, both those dams were removed, which restored river flow. And we are going to learn about this process from the folks who have been living it. This webinar is by no means the end of this story. Restoration is not a destination, it's a journey. And we are really delighted to be able to share the start of this journey with everyone here today. And so we're going to start by hearing from Save the Bay and the Bristol County Water Authority on how we got started. And then we'll move to Roger Williams University and Save the Bay, Roger Williams University, and University of Rhode Island talk about the data they collected and what they're finding. So a little bit of housekeeping. I'm going to ask that our speakers stay on camera, and so those should be highlighted for all of you when we start sharing. And then feel free to use the chat if you want to ask questions. I've also built in some time where folks can raise their hand and ask questions directly of the speakers after each presentation, and then a little bit of time at the end for any final discussion or questions that anyone may have. But please feel free to use the chat. We'll monitor that and make sure all the questions are answered. And if we run out of time, we will collect the questions and make sure that we can get answers for you. As always, we are recording this and it will be up on our website hopefully soon. And so if you missed something, feel free to go back. And if you can share it with your friends and everyone. All right, so without further ado, I am going to hand it over to our first two speakers, Stephen Coutu from the Bristol County Water Authority and Wenley Ferguson from Save the Bay, when they're going to start this discussion and share the journey that it took from being a former drinking water supply to a tidal estuary. All right, Wenley and Stephen, take it away.
Thank you, Courtney and the Estuary program for hosting this when Courtney was asking us for dates back in the spring. You wanted May, and we said, how about not May? Let's push it out. And we probably should push it out even a little further. So we're still doing work out there. So a lot of this is fresh off the press, but Steve and I are going to tag team this presentation, which kind of highlights the partnership that Bristol County Water and Save the Bay have had over at least 8 or 9 years that we've been working collaboratively on these dam removal projects. So Steve's going to start. And Steve Coutu is the director of Bristol County Water, and you came on board about 4 years ago. Is that correct?
Good afternoon, everybody. My name is Stephen Coutu. I'm the executive director here at Bristol County Water Authority. I came on board now a little over 4 years ago, and we're a drinking water supply agency, and one of the bigger projects that I was hired to oversee was a huge project for a new connection for an alternate water supply And I knew very little about this program, about the project that we're going to be talking about. And, I'm an engineer by trade and, trained to like build things and see things through construction. But I was asked to oversee, taking down obsolete infrastructure. That includes the dams and the former treatment plant. So just by way of introduction, we are a water supply agency, mid-sized agency, about 9 miles southeast of Providence, and we serve three coastal communities in Rhode Island: Barrington, Bristol, and Warren. We have a customer base of a little over 50,000, and on average, we supply 3.2 million gallons per day. Just for location purposes, you can see specifically on the upper right corner slide, those two yellow dots represent the two dam locations, and you can see how close we are to the coast. That body of water just south of the lower yellow dot is the Kickemuit River, and it feeds directly into Mount Hope Bay. So it is a tidally influenced river. So we are one of the oldest water supply agencies in Rhode Island, dates back to the late 1800s. The head of the tide dam, was the lower Kickemuit Reservoir Dam, was built back in 1883. It's not a very large structure, and it was built at a very narrow point in the river, about 130 feet long. And the treatment plant was built in 1908. And over time, I mean, initially it was a model facility, but as population grew, water quality became more of a challenge. And particularly as we get into the late 1900s, it really didn't provide sufficient quantity. I know back in even the 70s and 80s, it was frequently they were on severe water shortages, and they would put notices in the paper that they would only have maybe 1 to 2 days of water remaining sometimes in the summer months. Frequent overtopping, particularly during some hurricane events, led to even the water quality was even worse. You'd get salinity, high saline in the water because of the topping of a tidally influenced river. And that led to the construction of an earthen berm further up, about a mile up the river, to protect the drinking water source. And that is known as the Upper Kickemuit Reservoir Dam. And it's essentially not like your typical prototype dam with a spillway and outlet structure. It's basically just a large earthen berm, 1,000 feet long, and that would hold back the fresh water, and almost like an emergency thing in the event that there was overtopping in the lower dam. And you can see during the summer months, we get algae blooms quite frequently in the upper reservoir dam. You can see the picture in the lower right-hand corner there. This dam required some repairs, and during a routine inspection from DEM, it did not meet current regulations, and it required a lot of work and maintenance to upgrade that facility. So I mentioned previously, the water quality became more of a challenge to treat. New regulations came into effect for drinking water. It would require expensive treatment plant upgrades. And that led to Bristol County Water looking for an alternate water source. And so back in the late 90s, they tied into the Providence water system, which had sufficient water supply back in the late 1990s. And once that connection was made, that became really the water supply for this system. And the Kickemuit supply essentially became a backup right up until 2011, but it was just used so infrequently. It was decided just to fully decommission the plant in 2019. The reservoir system was then delisted as a public water supply from the Department of Health. And, now that we no longer needed the dams, coupled with DEM and OV because it did not meet regulations and would require expensive upgrades, Bristol County started looking into, well, why don't we remove the dam? rather than make upgrades to it, since it's no longer needed to hold back water. So that process started back in 2015. And then and we'll talk more about this, but with the hydraulic modeling and flood and water quality studies, that kind of led to an investigation of, well, if we're going to take down the upper dam, it's going to may cause some situation or problems downstream if we keep the lower dam. And so that led to looking into feasibility of removing the lower dam as well back in 2019. So from the Bristol County Water perspective, I mean, our goals were to remove obsolete water system infrastructure, which would eliminate any future maintenance costs to the ratepayers of the system, and also remove any future liability. But with removal of the dams, obviously it becomes a whole environmental improvement project, which I guess Wenley can speak more about.
So Save the Bay probably started getting involved in about 2016 or so, as Steve mentioned, when they were beginning to investigate potential removal of the upper dam. And we were very interested in this site because of the potential for water quality improvement, and really in particular, habitat restoration and marsh migration opportunities in the wetlands along the upper Kickemuit River. And then there was another lens to look at this project through, which was community resilience. Schoolhouse Road, just downstream of the upper dam, was subject to flooding, and this was another issue that these dams impacted infrastructure adjacent to or upstream of these dams. So just a little bit more background on the condition, which my colleague Ben is going to get into some of the pre and post restoration monitoring data. One of the things that we had very little information on was the environmental conditions. These impoundments were monitored by Bristol County Water for drinking water supply purposes. But as we were trying to understand the condition of the system for ecological purposes, we didn't have a lot of data. So back in 2000, working with Bristol County Water, we started participating in the Watershed Watch program. So we have 3 sites. And this data was really helpful as we were in that assessment stage and public outreach stage of a dam removal project. We learned that the lower Kickemuit impoundment, which we knew was getting overtopped, was flooding frequently with saltwater, but we didn't know the extent of the brackish water conditions. So Bristol County Water, the staff not only monitored the 3 sites downstream of the lower dam in the lower impoundment and in the upper impoundment, they also had a YSI probe and monitored 5 sites within the lower impoundment. And here you can see the average from the first season we monitored the salinity levels over time. Remember, this season was COVID, so we got a little late start that year. But you could see it was a drought year and how high the salinity levels were. And that brings up a later topic that Maddie's going to discuss. The salinity levels were so great in this former drinking water supply. It was already converting to a brackish system, and blue crabs were found within the lower impoundment. Which makes a lot of sense why the fish ladder that was installed back in the 2000s on this dam was never successful, because the spawning habitat wasn't suitable for river herring because it was too saline. This water quality data, here's our my colleagues wearing masks for those initial monitoring dates in the year 2020. Jim Vieira and his crew, Trevor using the YSI probe and the kayak, and a number of staff monitored over the last, we're entering our 6th year of monitoring. And the data initially also helped to further highlight how impaired these waters were for wildlife. There was a lot of concern of the public converting this from freshwater to saltwater. So we could share with this data in real time with the public as we were doing in the design phase of the dam removals. I mentioned earlier the benefit for marsh migration. The map on the left is a map highlighting where salt marshes can migrate under future sea level rise scenarios. And the brown overlay is where salt marsh could be under 3 feet of sea level rise. And that's the wooded wetland, mainly dominated by red maples, adjacent to the upper impoundment. And you could see those wetlands in the photo to the right. All the drone imagery was also collected by Bristol County Water Authority, Jim Vieira. We have hundreds, if not thousands, of photos of this estuary. So for looking to the future where our marshes have the ability to migrate, we're a very steep-sided estuary. We don't have a lot of room for migration. So this was a really important factor and also helped us secure funding for this restoration project. Here's just a brief timeline, a lot of words on this slide, but I think that some of the key components that Steve alluded to, it started looking at solely the upper dam. Save the Bay was interested in looking at the lower dam as well, but priority-wise, let's focus on the upper first. The modeling that was done by PAR Engineering about in 2018 determined that if we take out the upper dam, it's actually going to increase flooding at Schoolhouse Road, which is it happens to be a state-owned road just downstream of the upper dam. And it also would worsen flooding in the lower impoundment. So instead of looking at it as, let's do this upper first, then lower, we had to look at taking out the 2 dams simultaneously or within the same project. But most importantly, we also had to convince DOT to elevate this road. And it took 2 meetings. We involved the governor's office. It was a significant effort to get the state to, it's a very small road. It was only slated for repaving. And DOT, within a year after these meetings, prioritized the road from just a repaving project to elevating it and installing 4 new culverts underneath it. And without DOT's involvement, we couldn't have done this project. We wouldn't have been able to take out the dams. It would have worsened flooding of Schoolhouse Road. So that was a key piece and a key partner in this project. So once DOT was on board, they actually upgraded, got it permitted and upgraded it by that road by 2022. We got the permits in early summer 2023 and began construction on the lower dam removal first in the fall of 2023, and then the upper dam was finished last September. And we're still in the final grading adaptive management. A role for Save the Bay was helping Bristol County Water secure funding for these projects. Bristol County Water invested a lot in those initial, all the modeling that was done for the dam removal assessments, and we were able to get a CRMC Habitat Restoration Trust Fund for both the upper and lower, to help support the upper and lower design and permitting. And pretty much all of the construction funding came from a combination of state and federal funds. The Rhode Climate Resilience Fund was a huge, that was our first large amount of funding for the construction. And then we got a NIFWIF grant, had to go back to NIFWIF when we realized the bids came back too high. And then we were able to get additional funding to help cover those additional costs. And there's the total of about 4.3 million. A key component of this project was public outreach early and often. Bristol County Water created a community partner meeting that partner stakeholder group that we Probably started in 2018, 17 or 18. It included the town of Warren, the town of Swansea, the Kickemuit River Council, the Conservation Commission in Warren, local organizations like the Warren Land Trust, which is key for building support for this project, for those grants that every single one of those entities help write letters of support, as well as when we were in the permitting stage, because there was concern from the public. So it was good to have other members of the public and community organizations supporting the project. And we also did public meetings pre-COVID, during COVID. We did door-to-door outreach to abutters. And from those efforts, we identified public concerns that Steve's going to bring up, how we address those public concerns.
As Wenley mentioned, really a key point of this project is involving key stakeholders. And with Wenley's contacts with some of these environmental groups, it was really critical to not only establishing grants, but also gaining kind of public buy-in to the program. I mean, because you think of it, you have this body of water that's been there for now like over 100 years, and we're not out in the middle of nowhere. There is residential development built along the banks of the river. There is some farmlands. So there were concerns, and we did have a number of public meetings, and very heavily involved in those, because it was one of the first things I did when I came on board in 2021. We had meetings with the town of Warren officials, and then we also held meetings specifically for there's a condo association right nearby called Waterview Condo. So so out of those meetings, some of the key concerns came out was, one was flooding, and other private property impacts. Even though the reservoir is right here and it was a water supply, there were a number of properties up and down the banks of this water body that didn't have public water. They were on their own private wells, so they were concerned with salinity maybe encroaching upon their private well system once this became a tidal estuary. We offered to conduct testing pre and post dam removal, which we've done the pre already, and also just concerns of what is it going to look like, after this becomes a tidal estuary. There's a historic cemetery upstream of the lower dam that's been there for well over 100 years. However, the modeling showed that even in the worst case, that the cemetery would not be compromised. And there was general concern about the water quality impacts. Will the water quality improve? Will it impact water quality downstream of the dams? So we had to take all those concerns into consideration. So with respect to flooding, there's a roadway that winds along which was the lower reservoir, Serpentine Road, and there's a number of culverts that cross Serpentine Road. So the concern was, well, this becomes tidally influenced. What about if high tide, then the water is going to kind of come up and flood our farms. Well, the solution to that was we install flap gates along all the culvert systems. So those gates remain closed, and during rainstorms, they will open up, with the head behind them. So that addressed that situation. And we showed a lot of just images. Park Corporation did a really nice job of doing modeling. They had a actual kind of like a video of showing a model video of how the tide would come in and kind of fill the reservoir area, and then what the water levels would be like during low tide. And you can see how close these condos are located to the water body. And we also did some cross-sectional views so they can get a sense of what, the final outcome will look once the dams are removed.
So that modeling, as Steve mentioned, was really important part. Corporation participated in the public meetings, and there was a lot of response to those public concerns in the design process, which helped us when we got to the permitting stage. As I mentioned, the first step was upgrading Schoolhouse Road. The images on the left show the roadway, low line. It flooded during large precipitation events. There was one culvert that was in operation. There were two or three other culverts, I think two other culverts, but hardly visible. And here you could see the construction in 2022, and then the image of those new culverts from the water level post upgrade. The lower dam, we had a fun year. The winter of 2023-24 was not the time to be doing a dam removal at head of tide. Between precipitation and extreme tide conditions, it was a challenge, but it was removed fully by the spring of 2024. And there you can see actually the fish ladder that I mentioned. This was the head wall for the fish ladder, which was that the entire structure, the spillway and the fish ladder was removed. We couldn't remove the bank to the right because that was privately owned by the condo association. And this is from Child Street, just downstream. We worked with the Division of Marine Fisheries at Rhode on identifying that there were a natural set of oysters downstream of the dam. So here's Ben and Jim Vieira in August of 2024, finding those oysters, and then we moved them with oversight from Division of Marine Fisheries, so they would not be impacted during the construction phase. The upper dam removal started actually in the fall of 2023 as well. You can see it was a pretty sizable berm. They started lowering it, and then there it was lowered. They could not breach it, of course, until that lower dam was removed. So they finalized the removal in the fall of last year. And we've continued to be doing some work. Oh, here it is, the upper and those wooded wetlands adjacent to the upper at low tide and then at high tide from this spring. Thanks, Jim, for your drone imagery. We decided to keep the part of the embankment on the right. We worked with PAR Engineering and Ben Gaspar on trying to determine the elevations for wetland vegetation. Since so much of the former wetland had subsided due to the over 140 years of impounded water, we want to create some areas where wetland vegetation can grow. So we were just out at that site grading it over the last month. We had some cost savings because there wasn't as much sediment mobilization. So we were able to remove, this is an image of the berm on the western side of the river that was brought down to the elevation of wetland on the left side, the north side. So basically this berm extended, if you could see my cursor, into the wooded wetland about, I'm forgetting how many feet, maybe 200 to 300 feet. So we were able to remove all that fill as well. And that's going to be part of a ongoing wetland restoration effort. And here we are doing some final grading. And next steps, we will be, the contractors hopefully out there this week seeding. We're going to be doing some planting, small amount of planting of that low berm area this early summer, and then wait till the fall to do the wooded wetland plants or woodland wetland plants in under better growing conditions in the fall. And then we'll continue to work with Bristol County Water on long-term monitoring They're focusing on water quality through Watershed Watch, and we're continuing to help with the vegetation monitoring and that Ben will talk about, and elevation monitoring. And we also realize there's going to have to be adaptive management and looking at hydrology, looking at invasive plants. And we have two more slides, project challenges. And Steve might want to chime in here. The permitting process was complicated because the first dam, the lower, was under CRMC jurisdiction. The upper dam was under DEM freshwater wetlands jurisdiction. And of course, we needed an Army Corps permit, but it just added to the length of the permitting timeframe. And Steve, do you want to chime in?
Yeah, just quickly. I mean, we received our Army Corps permits, and with that came time of year restrictions as to when we could work within some of the tidal zones. And so we were challenged with receiving our remaining permits, and around the same time of ensuring that once we receive those permits, that we'd be able to work and not lose a whole nother construction season. And around the same time. Due to the length of some of these permits took to receive them, the cost ended up being higher than the engineer had estimated because we probably lost maybe about a year's time than we anticipated for the permit duration. And then, as Wenley mentioned, work during the winter months was a challenge for the lower dam. But I have to say, once they got the water under control at that location, and after 10 years of planning and permitting, the actual superstructure of the lower dam came down in about 2 days. And there was a concern with the amount of sediment removal that would be captured. And our engineer had estimated that there'd be quite a large amount of sediment, and that did not be the case. So that did result in some significant cost savings in the project.
And one thing I did forget to mention, there was some contaminated sediment from water treatment, copper. And so there was some offsite removal above the lower dam. But that was the only offsite removal of sediment. Some of the ongoing challenges, as I mentioned earlier, the modeling predicting what was going to convert to wetland, we're not seeing the wetland vegetation in the lower impoundment colonizing these mudflats because it's the marsh or the mudflat, that exposed mudflat is too low at this point in time, is our prediction. We are seeing some colonization by some brackish species. So that is something we've been experiencing, trying to assess through the vegetation monitoring that Ben will share. But we have been observing a lot of wildlife use of both the former impoundments, now the tidal creek, and those mudflats. So water clarity is much better. Bristol County water staff are noticing osprey feeding in the lower where the lower impoundment used to be. The waters were too opaque for the osprey to feed there prior to dam removal. This winter, eagles were feeding in the lower estuary. A lot of shorebird use and wading bird use, shorebird use of the mudflats and wading birds at low tide along the tidal creek. It's interesting in the the former upper estuary, it is a fresh tidal system. So you are getting brackish waters in the creek itself, but then along the flats, it's at this time of year, you have a freshwater lens. So we're still seeing painted turtles up there, a water snake, tons of snapping turtles. But meanwhile, in the channel, we're seeing mummy chugs, grass shrimp, and eel. So it's actinophores, comb jellies. So interesting to see how this system's responding. And we will continue to do assessments of wildlife response. And this project, you saw the suite of funders that supported it. We also have the rest of the crew that's going to be speaking, Roger Williams University, the EPA, Atlantic Ecology Division has provided guidance. NOAA Restoration Center staff, Jim Turek, who just retired, he was instrumental in providing guidance on this project, as well as all our community partners in the town of Warren. If the town of Warren's former town manager, Kate Michaud, had not said to DOT that we need this road upgraded at Schoolhouse Road, we probably wouldn't have this project going forward. So really, it was a real strong partnership at all levels. So thank you. And I think, Courtney, we probably went way over time. But if there isn't time for questions, we could pass it on to Ben, or I'll defer to you.
Well, there is one in the chat that's from Heidi, and she was questioning if the monitoring that is being done, is this required by your permits or voluntary information gathering?
So, the water quality monitoring was something that I was very interested in getting some pre and post data to assess benefit, if any, of dam removal. And then that was all voluntary. For the NIFWIF grant, we were required to do monitoring of ecological response. And Steve, I believe in I know we shared our monitoring plan in the permits. So but we were already proposing to do it anyway. So it's funny, I'm not thinking of it as a requirement because we were already underway doing this monitoring. I can't recall if it was, Heidi, if it was required under any of the permits, but we could get back to you with that.
And she also did comment that the subsistence and lack of regeneration of salt marshes on exposed mudflats is something she's seen from other tidal flow restoration projects. So there might be some good discussions there to mutual benefit to bring those areas back as you continue the restoration journey and grading the site. So with that, I'm going to ask Ben to share his screen. So Ben is going to talk to us about the monitoring metrics of this and walk us through what our initial findings are. And Wenley and Stephen, there is another question in the chat about historical surveys, so feel free to type in answers if you know that. All right, so Ben, take it away.
Just had to turn up my volume. Can everyone hear me now?
Yes, but the screen share, I think, has
Let
gone
me try
away.
this again. One sec.
Okay, you're doing great.
Okay, is that the presenter mode now for everybody?
You're doing great. We got
Okay,
the full
excellent.
screen.
Everyone, my name is Ben Gaspar, Save the Bays. You probably have guessed. And I'm going to give you a few quick overview of some of the things we're monitoring and some very preliminary results. And as you can see, there's Joel on the left out on the river. So as a visual to some of the things Wenley touched upon, I wanted to create kind of one master map that showed a lot of what different folks are doing. And so a few of the things on there, you can see the first thing listed in the legend there, those are the transects. So Wenley and I have them kind of going up and down the river. Some of the locations are the same as PAR had for some of their baseline data collection. And basically we have like 5 in the lower, 1 in the upper, 1 in the estuary. And these are where we're monitoring our vegetation every meter. So we're doing a percent cover. You also can see some of the water quality that Wenley touched upon. You can see the 3 locations for watershed watch collection. You can also see the 5 locations in the lower where Jim Vieira has been doing that YSI collection, May through October. You can also see there's 3 stations we've been monitoring the in-channel water levels and also dissolved oxygen and salinity. And also you can see some of the Roger Williams University riparian sites there, kind of out on the right where that freshwater input's coming in. And so we're going to touch base about a few of these as we go. There's also other research going on people are going to speak to, obviously like blue crabs, gas flux. There's also a few other things I didn't want to get lost, like some oyster recruitment work Rydam's doing and some NRCS work happening this month. So jumping into the vegetation quick. So basically this last season, we got our first year of post. So just for the lower. So, Wenley and I were out there doing the percent cover of the vegetation. This was the first growing season where, the lower reservoir had become tidally influenced. You can kind of see in this bottom photo here, we started monitoring. It was just like, a reservoir. It was a big pond. So a lot of it was done by canoe. And even to like measure some of our transects, you had to be in the canoe because you couldn't physically walk around in the soft mud. And then some of the transects do extend a ways into the kind of the riparian area there. I was looking at some of the vegetation data, and I want to say we got almost 40 different species of plants. And a lot of it, what you would expect along the banks of here, red oak, crocus species, a lot of, I want to say 20 to 15%. Then also getting into, some of those brackish type plants. Here's some quick bar graphs. Can obviously, we're trying to look for some of the species that might have detected the biggest levels of change, in 1 year post. Obviously bear went up. We're sampling these sites mid-tide, with some of those exposed mud flats. That's where a lot of that's coming from. And then obviously the typha, no big changes yet. Also looking at kind of the button bush, looking at the poison ivy, some of those freshwater things. Be interesting to see how statistically significant some of these are with another season. So we'll be doing these again. This year will be great. We'll do our first post in the upper and our second year in the lower. Also keeping an eye, as Wenley mentioned, the invasives are present in this system. A lot of the banks on kind of the eastern side there are kind of steep, kind of shaded, a lot of trees, but there is a bit of a shelf. And you can kind of see these two photos on the right. This shelf kind of consists of some sparse phragmites where the water's pretty shallow. And then we also, as we kind of go up the lower reservoir, you do have these stands of typha, and some of them do have phragmites mixed with them. And then as you go more up the lower impoundment, kind of the northern reaches of it, it's a very established typha. And then there is a little bit of phragmites above in the upper impoundment. So we'll be monitoring these again this year to see if any of these patches, start to expand or anything that would trigger some adaptive management. Also jumping into the water quality now. So big shout out to Bristol County Water Authority and also Ian O'Hara, who received some of this data just last week from Watershed Watch and quickly was compiling some of the 2024 data so we could share with you in real time what we're seeing. But on the upper left there, as Wenley mentioned back in 2020, is some of the preliminary, documented the fecal chloroform annual levels here in both impoundments. And as you can see, is fluctuating year per year, talking with Ian, a lot of this, these are going out in set date and times, it's a Watershed Watch protocol. So you are going to have some big fluctuations where if you went out after a rainfall event one time, and then maybe the next time you don't. So you kind of have those, it isn't always just the baseline dry sample. But on the right side here, this is starting to get really interesting now. So the 2024 data, now when we start going out between those three Watershed Watch collection points, we can start looking at some differences between the upper and lower. So this first one here is fecal coliform levels. And as you can see in the upper, in all cases, every month, so this data on the right there, these are the same day sampling, upper and lower. And you can see in all cases, the upper impoundment had the elevated bacteria levels. This is going to be really interesting. Monitoring it again this year, we can start to theorize, if some more mixing is happening, we'll soon, presumably down in the lower, the tide's going in and out now. Very similar for the nutrient levels as well. The annual means, all those were slightly higher than the first post measurement for the lower reservoir. And also the 2024 data, you can see almost every single month, the nutrients, both for total phosphorus and total nitrogen, were higher in the upper than in the lower. Again, the lowers become tidal now. So you have the saltwater, things are mixing, turning over is what we're theorizing. I think it's going to tie in nicely, Joel, with what you share as well, with some of those tidal signatures we saw develop as soon as the dams were removed. Also kind of getting into some of that May through October YSI data that Jim's been collecting. It's really neat to kind of see, I think Wenley showed the 2020 or 2021 data that first year during COVID, but it's been interesting to see those salinity levels just continue to rise, especially after a year ago when that dam was removed. And then also continuing with the dissolved oxygen. I'm not sure, Joel, how this will match up with your data set of increased DO levels, but it's been pretty interesting. All five of the lower impoundment stations that Jim has been detecting increased levels of dissolved oxygen post-dam removal. A couple other surveys just didn't get lost in the shuffle. We also, as Wenley mentioned, doing some cross-section surveys, both using an RTK and laser level when the tree canopy was too great for connectivity, and also working with Roger Williams University to get all the water levels into NAVD88 datum. So we could basically be looking at stuff in the channel and the stuff in the riparian areas. And that's kind of just a neat snapshot of one of the three stations. We have a very large diameter PVC well for dissolved oxygen. We have some conductivity sensors running and some water levels, as Joel will get into. And I want to say it almost touched 2 years continuous water level monitoring. And then also other things up there like JA at Rydom, helped us with the oyster relocation, but also was really interesting. He was talking about potential for oyster recruitment. Thought this was interesting, and he's looking at kind of like the substrate and the lower impoundment that's quite muddy. But would oysters potentially relocate? Maybe if there's something, some like shell or some kind of rocky habitat to attach to. So he's been doing a study where he's been putting out oyster castles to see if there's any recruitment, if the water quality improved enough and the substrate was available. And also Jim Tureen from NRCS has been out with the Rhode Island and Connecticut soil crew mapping, updating the state soil maps. I'm not sure if Jim's using the VibraCore on his boat. You guys probably know, but I want to say it was out last week even. And so it would be pretty interesting to see what he sees for soils out there. And again, thank you to everybody. If I didn't have your logo, I apologize in advance. And if I have time for a question or two, I'm happy to take that. Courtney, you probably have the best sense of what time frame we're on.
Yeah, we definitely have time for one question. If anyone wants to hear anything
Yes,
from Ben.
I do.
All right,
Can you hear
Richard,
me?
go right ahead.
Okay. Have there been any core samples done since the dams have been removed, in both the upper and the lower?
Let's say, did anyone see Jim up there? I know he was in his boat last year when I was out with him. We VibraCored. They got a pretty good boat out of Connecticut that's very shallow draft. I assumed he was coring with the VibraCore. If not, it was some kind of handheld corer. Because NRCS does a soil texture. So I'm guessing they're either like bucket augering or VibraCoring. But in order to
How
collect
deep did they go?
the VibraCore is like point of resistance, could be like 4 feet or so. The bucket auger and stuff like that might just be like 1.5 meters, something like that. But he literally started
What
that.
did they find below the mud?
I don't know yet. They did that in the last 2 weeks. He literally was out last week. So,
So will all that mud be removed, or a
no,
good portion of it?
he's
Because
not.
that's all sediment while it was sitting there as drinking water.
It's
So all the
not.
sediment dropped down, so that should be all cleared out before the process goes forward.
This is a little bit different. This is an NRCS project where they're required to map the soils in the state. So that map I showed, they have a lot of them classified. They had skipped to this area because it was classified as open water. If it becomes tidal, it is part of their jurisdiction to map the soils of the state for more of it's not a removal of the soil, it's a testing of the soils.
Thank you.
No problem.
All right, any other questions?
Thank you.
All right. Hearing none, I am now going to turn over the conversation to Joel Singley and Maddie Greenhalgh from Roger Williams University to talk about all of their monitoring that they were able to do as part of this project. So take it away, Joel and Mandy.
All right, thanks, Courtney. So we're going to be talking about a lot of the data, specifically hydrologic data that we've been collecting throughout our monitoring efforts. I'll start just by recognizing our team. So I'm an assistant professor of environmental science here at Roger Williams. I came along into this whole project a little bit later than most folks. I've only been in the area for about 3 years. Driving by one day, I saw water going the wrong way over the dam and got really interested in it. And then fortunately, lots of folks were happy to have us involved. Mandi, I'll let you introduce yourself briefly.
I'm Mandi. I'm a rising senior at Roger Williams University. I'm working on a Bachelor's of Science in Environmental Science, and I have a minor in History and Sustainability Studies.
And Mandi's been involved from the start, originally through an internship that was supported by the Narragansett Bay Estuary program. And then, of course, Ben has been immensely helpful, especially dragging the canoe through the mud, ice, all the other good times that we've had, scraping barnacles off sensors. So I'm primarily a freshwater hydrologist and critical zone scientist. So I think about forests, streams, lakes, those sorts of systems. This is a slight switch for me. Our primary motivation in terms of thinking about this site and this project is related to the fact that this is really rapid tidal reconnection. And having that happen in a site where we have these low-lying riparian forests was really interesting to me, given some of the prior work that I'd been doing, and also as a student training opportunity through our courses and research opportunities as Mandi's been involved in. So our main objective, as everyone else was taking care of the dam removal, the permitting, all of that, was to characterize the short and long-term hydrologic dynamics, both for the surface water and groundwater throughout the project. I listed a couple example research questions here. We're not going to dive too deeply into all of these. We're still dealing with what is truly a data deluge. We have so much data from this project over the last 2 years. As you saw from Ben's map, we have sites that are spanning from the estuary below Child Street into the upper reservoir. We focused on channel and riparian sites. There's kind of a suite of different measurements that we've been collecting. Almost everything has been collecting 15-minute data. So we have the suite of sensors that are out. I'll say a little bit more about each of these sites in a moment. But every single 15-minute increment, they're taking and recording measurements. So we have hundreds of thousands of observations about the hydrology of this system over the last 2 years. We had a meteorological station so that we could constrain some of what was happening in terms of forcing this system, as well as the ecosystem response. Again, that's all 15-minute data, all of these parameters operating continuously. We installed shallow riparian wells. These were mostly hand augered to about 2 meters deep. Some of them are a little bit shallower than that. They're screened to allow water to freely move in and out so we could get a good representation of the water table level. They're equipped with water level loggers, again, operating every 15 minutes. Some of them also had conductivity sensors. And then we periodically went out, and Mandi was responsible for making manual depth to water measurements so that we could calibrate and check the performance of the loggers, especially as some of these walls became a little bit more saline. As Ben showed you, we had surface water stations. So these are essentially large stilling wells. They were installed where the historic channel was to the best of their ability and anchored into the sediment with fence posts. Again, we had water level, we had high and low range conductivity to capture the really large fluctuations that were occurring with salinity, especially once tidal reconnection was established. And then we also had dissolved oxygen loggers. We're still working through the performance of those loggers. It's quite difficult given the biofouling as well as the big salinity fluctuations to accurately correct that data. And then lastly, we had riparian forest stations. These were mostly in that forested area along the lower reservoir. These are providing us with some soil moisture data as well as sap flow velocity. So how much water is flowing up the bowl of the tree. In other words, how much water they're using, again, at 15-minute increments. And now I'm going to turn it over to Mandi to provide just a little bit of a look into what all of this data allows us to see. And again, this is just a small snapshot of what we're finding so far.
So this data set begins when we first installed the wells back in late May 2023, and this goes all the way through October 2024. We do have more data, but at the time of making these graphs, I didn't have access to it. So at the beginning of the time series, you can see that there's lots of dips and falls, and these are driven by precipitation events. These are all rainstorms. The top graph is the lower channel, and the bottom graph is the upper channel. And as you go along, you can see that they kind of follow the same pattern. And then on the upper panel, you can see where the dam breach is labeled. And after that point, that light pink color becomes a larger fluctuation. And this is due to the tide coming in and out. And you can see with that, there's a change in how the well levels react. The peaks become a lot smaller and they kind of follow more of what the wells are doing. And originally, we found that the water within the wells was driven by evapotranspiration from the trees, meaning they're pulling the water out of the groundwater that they're using. And then after, it's kind of more driven by the tides, we've noticed. And as you can see, towards the end, the wells tend to go dry because there was not a lot of precipitation and they were a little bit farther from the reservoir, so there wasn't as much tidal influence on them. Here we can see a bigger zoom in on storm events. So in the first half of the panel, you can see the same storm event at two different sites. At the top one, you can see the transpiration signal, and you can also see it in the bottom, but you can see that there's a bigger difference in where the water table is. And after, you can see that there's a slight tidal signal in the upper site, while at the lower site, there is a significantly larger tidal signal, and there is no transpiration signal available in the groundwater. And these are wavelet analysis, so pretty much these help us determine what kind of signal is available in the water. So originally, before the dam removal, you can see that there's a 24-hour signal, which is the transpiration signal. And then after, you can see that there's a very steady tidal signal.
All right. And so what we'll be doing is eventually publishing all of our data from all of these sensors, as well as some of the resulting findings that Mandi and other students generate. This will all end up on HydroShare, which is a kind of hydrologic community portal. So these will be free and openly available. We're hoping to have those up kind of late summer, early fall. Mandi's been doing a lot of work to clean up all of this data. I'm not going to walk through all of these, but with all this data, there's a lot of things that we're going to be looking at, students will be looking at, and we'll be integrating into classes here as we think about this connectivity between freshwater and saltwater systems, as well as ecosystem restoration. And we are absolutely happy to have anyone reach out who has curiosity, capacity, or wants to dig into this data. We're happy to help people do that. Some preliminary takeaways from our hydrologic analysis so far is that before we saw this real dominance of water levels by storm events and the recessions that would follow. Now we're shifting into that tidal signal. That's both true for groundwater sites as well as the surface water. We've seen the water table direction is now changing. So we are getting flow from the channels out into the riparian forest. We are seeing the rise in salinity. I didn't show that this time, but some of these wells do have much more brackish water now in them. And then we're losing that transpiration signal, so that tree water use signal in the groundwater, which is potentially due to them shifting where they're pulling water from, which is probably also related to the changes in salinity that are occurring and potentially some stress for those plants. There's a lot more data, and we're happy to take questions and invite other people to collaborate with us on this.
All right, thank you, Joel and Mandi. We did have a couple of questions in the chat. One was the diameter of the stilling wells. Do you remember what was the diameter of those stilling wells?
Ben, correct me if I'm wrong. The big ones were like, what were they, 4 or 6 inches? They're 8 inch. They're really big. The smaller ones, the riparian wells, were 1.5 or 2 inches. Those were mostly sized to allow us to get the sensors in them.
Awesome.
And if you need 8-inch wells, you got to go to a commercial supply place. The box stores don't stock over 6-inch. We had to go to like heavy duty to like the industrial park, and yeah.
So if anyone here ever needs to drill an 8-inch well, Ben knows where to get the supplies. And then the last question was, do you have any evidence or information on if the water level has impacted the surrounding private wells?
I don't. That's maybe something that Steve could talk to, because we're focused really, really shallow wells and right on the riparian corridor.
Okay, so
Yeah, we will reach out to the residents again, those are wells, the ones that we've sampled previously, and the plan was like after a year we'd go back. So we have not yet done that.
okay. So more to keep us on the edge of our seats as we keep talking about this. And then Ben has asked, is the altered water use signal a precursor to a transition away from the riparian forest?
It certainly could be. It's something that we'll have to watch over a long period of time to see what happens, especially with these red maples. The thing that's kind of making this a complicated prediction is the water table is apparently dropping some, as would be expected from where the mean water level is. But then you're also seeing this rise in salinity. So in some ways, these trees might be exposed to more saline water, but it's a little bit deeper, so they might be able to draw from fresher reserves up in the soil above where that salt water is. So it's kind of a TBD on what's going to happen with these, and we might also see some differences between the oaks and the maples that are in the area.
Awesome. All right. And so now I'm actually going to try and keep us little on time, and I'm going to ask Maddie Sachs to share her presentation. And now we're shifting away from water chemistry to blue crabs. So take it away, Maddie.
Hi everyone. Thank you guys so much for joining us today. I am a marine ecologist over at Inspire Environmental in Newport, Rhode Island. But I was originally a master's student in Serena Moseman-Valtierra's laboratory at URI. And this work was done while I was doing my master's research. And our collaborator was Jason McNamee over at RIDEM. So basically, our research was about blue crabs pre-dam removal. So all this data is from before that restoration process began. But a little bit about blue crabs is that they are a dominant and keystone salt marsh species and predator. They have spatial segregation of the sexes with ontogenic life cycles based off of salinity gradients within estuary systems. And they can act as a biocontrol for introduced species such as the European green crab, which you can see in this video to the right. And in the center, you can see just how the females and males have that morphological differences to tell them apart. So these are their apron shapes here, and also you can tell by the claws. And then the map on the far left shows their autogenic patterns based off of salinity. So we collected blue crab data in the Warren Reservoir, which is north of that lower dam that just got removed, and then two secondary locations to compare that data to at the Shellfish Management Area and the Two-Set Marsh. So you can see those over on the right-hand side, what they look like. So here you can see the fish ladder that was within that lower dam, and that is likely how blue crabs were moving in and out of this site. So the main objective of our work was to characterize the blue crab population and habitat in this anthropogenically altered system at the Kickemuit River to evaluate their abundance levels and their tolerances to degraded conditions pre-tidal restoration. And we had two different hypotheses of what might be happening in this system for blue crabs, which was that the blue crab is evenly distributed between the upstream and downstream sites of the dam. And alternatively, that environmental factors that define benthic habitat, such as substrate or water quality, may affect the blue crab abundance, their size, maturation, and this could be due to the spatial segregation of sexes and that ontogenic life cycle that they have, and the dams causing anthropogenic and tidal alteration to the system. So it's kind of a dynamic question we were trying to ask and figure out what was really going on here. So in order to monitor blue crabs, we followed a protocol published by my colleague, Dr. Kersey Sturdivant, and we used commercial blue crab pots, which we had 10 at each site. And the way that these pots are designed is for maximum catch in the fisheries industry. So they're segregated into two separate chambers. So the upper chamber is called the parlor, and then the lower chamber is called the kitchen, where the blue crabs will enter, and that is where bait is usually stored. So that's why they're being attracted to these pots. Oops. And so here you can see what our sampling regime was like. So originally at the Warren Reservoir, we wanted to do it along like this gradient here to try and capture the like distribution of the crabs in this like slender area. But as we started deploying pots from month to month, we were seeing bycatch species such as painted turtles, so we wanted to mitigate that as much as possible. And so we then just clustered the pots by the lower dam, so that would hopefully inevitably capture any blue crabs that were moving in and out of this area, so that if they were passing up and down, they would hopefully interact with pots. And the reason why we were seeing such a high bycatch of painted turtles after a while was because of the salinity dropping significantly from season to season. And here you can see what the sampling regime was like at the shellfish management area and the 2-cent marsh. So we tried to keep it pretty uniform as to the Warren Reservoir. And the main non-target species that we were seeing here were the two different spider crab species we have here in Rhode Island, the portly and long-nosed spider crabs, which are now trying to develop a fishery for that as well. So along with blue crab data, we also were collecting water quality over time to try and compare what these benthic conditions were like to see how blue crabs may prefer one area to another. And basically what you're seeing here are figures of our results of repeated measures ANOVA over time. And so basically the ANOVA showed us that there was a significant difference in mean salinity and dissolved oxygen levels in the north and southern sites of, below and above the dam. But temperature did not show any significant difference. The southern site had significantly higher salinity by around 18 parts per thousand, but that was more so because of the sites having different tidal exchange capabilities, and that was because of the dam, obviously, and this was not something that was captured over time as being significantly different. And the dissolved oxygen levels were significantly different between the northern and southern sites by around 3.5 milligrams per liter, and dissolved oxygen and temperature were significantly different across months. So that just captures the seasonality that can happen over time here in New England. Obviously, we have very different seasons, and dissolved oxygen and temperature are pretty much linked when measuring for these types of parameters. And so here you can see on the left-hand side a histogram of blue crab catch, and then on the right-hand side is just a bar plot of what the catch was like month to month. And based on raw catch, the abundance was much higher in the southern sites compared to the north, but however, our zero inflated model showed that the data was indeed zero inflated. So it was the zero inflation was higher in the northern sites. And then our bar plots show that the Kickemuit River system overall was very much male dominated. As to females, they were more present in the southern areas, and this is also because of salinity. So males tend to prefer more fresh to brackish conditions, whereas females have a higher preference for higher salinities. So again, this tidal exchange that was not happening at the river allowed for the sexes to kind of be separated. And we kind of, over time, realized that on top of the dam, creating that salinity difference, this is also part of how blue crabs function within their life cycles. And females tend to travel up into estuarine systems from bay areas to find mates and copulate. And so we then realized that there was a resident male population, but transient female population at the Kickemuit River. And so our statistical results from this zero inflated model kind of shows both abundance and presence. So there's two models running within this one parent model. You can think of it like that. So the account model is telling us how many blue crabs are there, and what was really driving that was salinity and the substrate. So they preferred mud, and so they had a significant positive correlation with blue crabs, and painted turtles and spider crabs had significant negative correlation, but I'll get into that further in another slide. And then the presence absent model shows us if these zeros are true zeros or not. So when we deploy pots, if we brought them on deck and there wasn't a crab in there, that's what I'm talking about here. And so salinity and mud/detritus had significant negative correlation, or was causing blue crabs to may or may not be there. And painted turtles, but not spider crabs, had significant negative correlation. And we also compared our data to the GSO fish trawl data collected by Jeremy Colley's lab. And this also shows how salinity is a major factor for blue crabs in Narragansett Bay. And so on the right, you can see that at the two Narragansett Bay sites that the trawl samples at is completely female dominated, whereas at the Kickemuit River on the left-hand side, it is entirely male dominated. And so these data are also showing how seasonality can affect blue crab abundance and residency within different systems as well. And so based on this data, temperature and dissolved oxygen had an inverse relationship, which impacts blue crab abundance at extreme levels. We saw this within a heat wave event during July of 2023, where it was extremely hot and dissolved oxygen was very low. And we didn't catch any blue crabs that month within the Warren Reservoir system, except for one mortality. But we don't believe that there was extensive mortality during this time, because abundance rebounded quite significantly after that in subsequent sampling. And salinity was significantly higher in the south side, which may be why there was a higher abundance of females there. And here you can also see that, if you can see my cursor, where that mortality or lower energy expenditure may have happened at the Warren Reservoir. And so here we see this abundance zero inflated trend within the different sites, and these were driven by the two different species that we were also catching on top of blue crabs, and that is something that has been captured in the literature as gear saturation. And so you can see here in these videos that on the left-hand side, this pot is completely overtaken by spider crabs and channeled whelks, but there aren't very many blue crabs. So we realize that once, the pots start to fill up with a lot of animals, blue crabs may, although they are a dominant benthic predator, they're going to want to allocate that energy elsewhere instead of wasting time trying to fight for resources. And then on the right-hand side, you can see that the blue crabs that are in that pot are in that upper chamber called the parlor. And the reason why they're there, even though the pot is so busy with other animals, is because of the fact that they're in that upper chamber. So they were there longer. They entered the kitchen and then traveled upwards into the pot. And so then all the other animals came in after them. So that's why they're there in the right-hand video instead of the left. So the Kickemuit River had some pretty interesting community composition trends, and at the north of the dam, it was mostly aquatic to estuarine species cohabitating with blue crabs, such as painted turtles. And then on the right-hand side, you can see what the community composition was like at the southern sites, the shellfish management area and the Tussit Marsh. So other species like the green crab, the whelk, toadfish, periwinkles, and the only species that we captured on either side of that lower dam was the blue crab. And so the lower dam inevitably created different sub-ecosystems because of the blocking of tidal exchange, and that drive the salinity differences. And then that's how we were able to see that the differences in salinity also were linked to the different species that we see. And this is corroborated by the salinity being significantly different between sites and the significant relationship between salinity and blue crab abundance. And so after doing much statistical analysis, we were able to reject our alternative hypothesis and accept the null that the blue crab is indeed evenly distributed between the upstream and downstream sites of that dam. So they are quite resilient despite physical barriers and poor water quality conditions. And this is because of how mobile that they are. They are a swimming species under the Portunidae family. And so they just are kind of bulletproof in this system. And so with that, we can try to hopefully one day create a subsequent sampling effort for further research after this, since this dam has been removed now, there's now an opportunity for like a natural experiment or before after control impact study to monitor the ecological response of the removal of the dams from blue crabs and what increased tidal flushing and improved water quality does for these species, and compare the results of pre-dam removal to post-dam removal blue crab abundance. And so there was a myriad of collaborators, and it really took a village to make this work. And it was such a wonderful experience for me. And I'm just very grateful to everyone that did help. And I know a lot of you are here today, so I'm so glad to be able to share this with you again. But here's some more fun photos.
All right, thank you, Maddie. So, in the interest of time, I would love to hear from Serena to talk about greenhouse gas fluxes. So she's done a lot of work in understanding how the gas exchange and carbon cycling in these areas. So I'd love to hear from her. And if you do have any questions for Maddie, feel free to put them into the chat and we can keep monitoring them. So I will let Serena take it away.
Hi, everyone, and thank you very much, Maddie. You gave everyone the impression that I have a charismatic lab with beautiful marine species all the time, when really what I study most of the time is invisible, or it looks like mud. And like Maddie, I'm going to essentially end this presentation with a question that still needs to be tested. And so our goals really are to invite collaborators who might like to expand or continue our data set or have ideas for future funding to continue the work. So I'm talking about methane, which we hypothesize will now be largely avoided thanks to the removal of the dam. Marshes, you must know, have many benefits, and just one of those benefits is the ability to sequester carbon at very high rates. Salt marshes are one of the high bars shown on this figure, and notice that they actually exceed, in terms of the rate of carbon boreal per area per year, that of tropical forests. And this is a picture of a core that my student provided showing you thousands of years, essentially, of carbon that has simply been built up over the years and remained in place under a nice protective blanket of water. The carbon story is not just about carbon dioxide, however, and so our lab is looking at methane, which is also a potent greenhouse gas. Like carbon dioxide, it's been increasing since pre-industrial and post-industrial times. And the largest source of methane naturally is wetlands. However, it's predominantly freshwater wetlands that contribute to that. And then anthropogenically, we are adding methane through things like livestock production and fossil fuel consumption. But we care about methane because it's got a global warming potential of about 25 times that of CO2. That means that it's got the biggest bang for its buck in terms of producing the most heat per amount that is emitted. So if you had to make a choice between what form of carbon to release, you might like CO2 instead of methane. So I mentioned that wetlands are sources of methane, but salt marshes are not. They have salinity, which consists of sulfate, and we think that most microbes that produce methane are outcompeted by the bacteria that use and thrive in the presence of sulfate. So the top left picture is showing the classic salt marsh, the ideal salt marsh, in which there's a big blue arrow pointing down. That's carbon being taken up and sequestered into those soils. There's a small little orange arrow of methane pointing up to the atmosphere. But when we impound a wetland, as we do in many places along the coast, and as we did at Kickemuit for so long, that system becomes fresh. And the fresh system becomes a source of methane. There isn't really a big change, we think, in terms of the carbon dioxide. So it's the methane that's driving that signal shift of a positive climatic forcing or a source of greenhouse gases. So my colleagues and I several years ago presented the idea to the community that by restoring tidal flushing, essentially one can cut back on what would be otherwise anthropogenic sources of methane. All of the salt marshes that were at one point in history converted to freshwater emit methane that would not have been there had we not manipulated and restricted tidal access. So this is an idea that we've been poised to test at Kickemuit. There are data that support this idea. On the left, there's this now canonical relationship, a -1, between salinity and methane fluxes. So there's a negative relationship between that, and the gray box behind it is showing the equivalent of carbon dioxide uptake or carbon sequestration. And so where methane is greater than that gray box, the systems are a net source of greenhouse gases, while if they're below that, they're a carbon sink, as we would ideally like them to be. And I'll just point out that Kickemuit was poised on the cusp of this critical salinity value of about 18, but above which the IPCC and scientists have largely estimated that methane emissions from wetlands will be 0 or negligible. So with colleagues who were better equipped than me at the time, we were able to measure methane using this, what looks like an inverted bucket. I think, in fact, that's what it is, with, yes, high-tech pool noodles. And that was connected to a greenhouse gas analyzer in the item that looks like a gray suitcase. And they conducted these measurements at the spots where you see marked by yellow pins through the lower reservoir. This was all done way back in November 2021. It was a beautiful day. This is what some of their data looked like it's quite sparse, but it just shows you a rough idea of what the methane fluxes look like. And they, in fact, have a hint of relationship to the CO2 levels. There were less data collected in what my colleagues call the middle and upper reservoirs, but they fell interestingly kind of in the middle of what was measured, the range measured in the lower reservoir. And then my lab got lucky and we got one of those gray suitcases. And so we've been able to expand our data set of methane. And we brought out our analyzer in July of 2023. And we used a floating chamber, which one of the students in the blue t-shirts is showing you. We went to the same area that USGS did, and we just expanded the data set. These are some of the data that we measured at 10 sites, which were distributed similarly to what Maddie's map of the crabs looked like. And the flux values that we measured in July were a little lower, but in the range of what USGS had measured in 2021. So it hints that there's some seasonality, but at least we were able to get comparable data with similar methods. And then we measured dissolved methane in the water. So anyone who's able to collect water samples and preserve them for us and save them would be really helpful because we could then look at this data post dam removal. What you're seeing right now is all before the dam was removed in June, July, and August. And there's a nice spread showing clearly there's variability over time. And so we would love more samples. What we're doing right now is working on designing a well cap that we can connect to our gas analyzer. And that would be ideal to position and test out in Joel's wells. And I think we'll be talking about that hopefully this coming summer, because the groundwater might actually be a source of methane, even if the system is now marine. So with that, thanks everyone for your attention. And Maddie and I will be glad to take questions.
All right, thank you all. So this was wonderful. I know we are right up at 2 o'clock, but if anyone has any questions for Serena or Maddie, we can squeeze a couple of those in. I actually have
Serena,
one.
we
Yeah.
can definitely work with Bristol County Water, and they are collecting samples monthly for the Watershed Watch program. So maybe we could have an offline conversation with Jim Vieira and his team. So let's put that on the calendar before their June sampling date.
Great, thank you.
So Serena, based on the levels that you've seen of the gas fluxes, do you think this, as the tidal restoration has been restored, do you think you're going to see that reduction in methane?
I certainly do think so. I compared the values that we observed with our floating chambers to data that I'd published in other wetland zones, including Phragmites, which we saw earlier from Ben's presentation. And that, to my knowledge, had been one of the largest sources of methane. And so what USGS and I were measuring was approaching those values. It's really pretty high. And then there's some astonishingly high methane concentrations that were observed by them in the dissolved water column in the upper reservoir. So anything lower than that is pretty likely.
No, that's great. And it'll be really interesting to see, when you're able to get more data, what that looks like and piece this part of the story together. And so now we're just at 2, so I want to make sure we are respectful of everyone's time, but thank you all for spending your lunch and a little some with us to learn about all of this stuff going on at the Kickemuit River. And remember, this is just the beginning. As every one of our presenters said, there's more data, there's more information to collect. This is a unique opportunity for really the region to keep an eye on what happens when you really take out dams and you restore full tidal flow. It's something we don't get to see very often in this area. So thank you to our presenters for sharing your information and sharing this story. And we look forward to seeing you all again and hearing more about this. And I just want to plug a little bit of the estuary program that if you're still thinking about connectivity of fresh and salt water, we are still working on this issue at the estuary program, and we are planning an event for the fall that's going to talk about this topic, much like the other events we've had before, where we've talked about wildlife and our favorite critters and plastics in the region. Now we are going to talk about getting ourselves back to restoring fresh and salt water connectivity. So keep your eyes peeled from us on that. And we look forward to seeing you all again soon. And thank you. Have a wonderful afternoon.